let's consider the first example. Now in this example, we want to evaluate the surface integral of x squared c over the surface S, where S is the portion of the plane x plus y plus c equals to 1 that lies in the first octant. So if we draw a picture, so we have the xy plane, xy, and then the c-axis. Now we have the plane x plus y plus c equals 1, and if you calculate this x-intercept, it should be 1, 0, 0. Y-intercept should be 0, 1, 0, and the c-intercept is 0, 0, 1. So that's your surface S. And since we consider the first octant, we should consider only this part. Now this is your surface S. On this surface, we are defined the function g. So that's your surface S. On this surface, we have defined this function x squared c. Okay, so the equation of this surface is x plus y plus c equals to 1. Usually we want the equation of the surface in this form. So let's solve this one for c. Then we have c equals to 1 minus x minus y. Okay. Now let's evaluate the surface integral. Okay. So we defined a surface integral in this form. Okay. So this is the way we define the surface integral. Now in this case, your g, so we have your g is x squared c ds over the surface S. This equals to double integral over a domain D on the xy plane. Now let's evaluate your g on the surface. So this is your g. Okay. So g is x squared times c. Now on the surface, your c value equals to 1 minus x minus y. So instead of c, we write 1 minus x minus y, because the c coordinate is given by this, and we define our function g on this S. So the c coordinate of this function g equals to the c coordinate of the surface, which is given by this equation. Okay, now we want to find this part. Should be square root of 1 plus, okay, what is partial f over partial x? Okay, I will evaluate these two quantities in the next line. So z equals to 1 minus x minus y. This is your f. Now partial f over partial x equals to -1. Partial f over partial y also -1. So now we can update this equation. So now you will get partial f of partial x is -1, so we have -1 squared plus partial f of partial y, which also equals to -1, so we have -1 squared dA over the domain D. Now let's simplify this integrand. -1 squared is +1, so 1 plus 1 plus 1 is 3. We have root 3, which is a constant, and let's take it out from the integral signs. And I'm going to distribute this x squared, so we will get x squared minus x cubed minus x squared y dA. Good. So still we have not figured out this domain D. So let's go back to the figure. Now your domain D is the projection of this surface on the xy plane, so which represents this part. Okay, we'll draw a new figure. Your domain D should be this triangle that you see on the xy plane. That's your domain D. Now if you look at your xy plane, so then you will see a right triangle like this, and the equation of this line should be, okay, now on the xy plane your c coordinate equals to 0, so you have 0 equals to 1 minus x minus y. This means y equals to 1 minus x. Okay. This is your domain D. That's your domain D. This is your domain D, and we have this area element dA. Okay, so now we can do this integral. Okay, and we can write dA as dy dx or dx dy, but I am going to choose this order of integration. Now if you think about the inner integral, that corresponds to the y variable, and lower limit of y is 0, upper limit of y is given by this line. In general, the y value is given by this line, which has the equation 1 minus x, and finally x goes from 0 to 1. Okay. Oh, okay. So let's integrate this. Root 3 times the integral from 0 to 1 of, okay, now if you integrate x squared with respect to the y variable, you will get x squared times y minus, again we have to treat x variable as a constant, so you will get x cubed times y minus x squared times integral of y is y squared over 2 dx. Now instead of y, okay, lower limit is 0, upper limit is 1 minus x. So let's apply these two limits. apply the upper limit first and then the lower limit. You'll get x squared times 1 minus x cubed times 1 minus x minus x squared over 2 times 1 minus x quantity squared minus, if we apply the lower limit, you will get y equals, since y equals to 0, your lower limit will give you 0. Then dx, the integral from 0 to 1. Okay, before we integrate with respect to the x variable, I'm going to simplify this integrand. So basically we have root 3 times integral from 0 to 1 of x squared minus x cubed then plus x to the power 4 minus 1/2 times x squared times, now if you FOIL 1 minus x quantity squared, you will get 1 minus 2x plus x squared dx. I think we can combine the similar terms. So you have x squared minus 2x cubed plus x to the power 4 minus 1/2 x squared plus x cubed. Now I am distributing this negative 1/2 x squared term. So negative 1/2 x squared times 1 is the same thing. And then negative 1/2 x squared times negative 2x will give you positive x cubed. And finally you will get minus 1/2 x to the power 4 dx. So this is just simple algebra. Now let's combine the similar terms. Okay, we have x squared here and negative 1/2 x squared here. So that will give you positive 1/2 x squared, and then you have this negative 2x cubed term and positive 2x cubed term. Give you negative x cubed. Okay, and then finally we have positive x to the power 4 minus 1/2 x to the power 4, which equals to 1/2 x to the power 4 dx. Let's integrate this. You will get 1/2 x to the power 3 over 3 minus x to the power 4 over 4 minus 1/2 times x to the power 5 over 5. Lower limit is 0, upper limit is 1. Apply the upper limit first. You get 1 over 6 minus 1/4 minus 1/10 minus, if you apply the lower limit, you will get 0 for each of these three parts, and the answer is this: root 3 times 1/6 minus 1/4 minus 1/10. This is the value of the surface integral.